welcome to my channel. And right here in this video, we want to evaluate the inverse functions. Right? So if you're given a function of x like this right here, say f of x is equals to the cube root of the numerator we have x minus 1, and the denominator we just have the 3. Then, to find the inverse of this function, that is to say, find a new function such that the composition of the new function, that is the inverse, okay, and the original function is going to give us x, that is the independent variable. So, f inverse is the inverse of the given function such that the composition will give us x. That is the rule for inverse functions. So, if we find a new function, f inverse of x, that is the inverse of f of x right here, then the function will be such that when we evaluate it like this, it's going to produce x. Then we know that the new function we just solved for is an inverse function. And here we go with this one, right? Okay. To solve for an inverse of a function, all we need to do is either you first of all go ahead and in place of f of x, okay, you can reduce the complexity by using y for it. So you can simply say let y be equal to f of x, like that. Now when y becomes f of x, so in place of f of x you just use y like this, alright? So you just say y is going to become cube root of the main thing here. I'm just changing the notation, right? I want to use y notation. Okay, so when you get this, the next thing you do is that you either, to solve for the inverse of a function, okay, you either go ahead and interchange x and y. That is to say, if x was here, put y here, and in place of y, you put x. That is how to interchange x and y, alright? Or, you from here solve for your value of x. That is to say, from here you make x subject of formula. Then after making x subject of formula, you interchange them. So you interchange before you solve for y, or you solve for x and you interchange. So let's try the two methods, alright? Very nice. First of all, let's interchange. This is the first one I'm going to approach with. Let's interchange x and y. So by interchanging x and y, we're going to have x is equal to cube root of cube like this of y minus 1 divided by 3. So from here, we'll make y subject of formula, and the function, or the right hand side of y is going to become the inverse of the original stuff here, okay? So we go ahead and make y subject of formula. Now, to approach that, look at this. This is the cube root function, so all we need to do is to say cube both sides. So we're going to have x cubed equal to, by cubing both sides, we're going to have y minus 1 divided by 3. In fact, it's pretty simple. We can just multiply 3 on both sides. We're going to have 3x cubed is equals to y minus 1. And from here, we just have that y is going to become what? Well, that will be 3x cubed plus 1. Now, this new y is the same thing as f inverse, that is, y was taking the place of f, alright? But this new y is the inverse of the original y. So we have f inverse of x is equal to 3x cubed plus 1. Okay, so this is that. If we were to approach in the other way that I told you, this is the second way to approach that. So this right here is just a function, okay? I will come back to use it to check whether it's really a function by using this rule here. But let's just use the two approaches, then we are going to get a unique result. So the second approach, I say instead of interchanging x and y, let's first of all from here make x subject of formula. So we had it to be y equal to, we had cube root of x minus 1 divided by 3. So we keep both sides, like I said. We want to make x subject of formula, so we have y cubed is equals to x minus 1 divided by 3. Okay, so from here we just multiply 3 on both sides, just like we did here. We're going to have 3y cubed is equals to x minus 1. And again, we just make x subject of formula by adding 1 on both sides. We're going to have that x is equals to 3y cubed plus 1, like this. Very nice. Well, the next thing is interchange x and y. Before we interchange x and y, then we make y subject of formula. Yeah. We make y subject of formula, and now we make x subject of formula, then we interchange x and y. You know, by interchanging, let me just write it down. Let's just what I wrote. Okay, so by interchanging x and y, we're going to have y to take the place of x is equal to 3x cubed plus 1, like this, alright? And recall that this y here is just an inverse of the original function, so we just have it to be f inverse of x is equal to 3x cubed plus 1, and this is the same thing as this. Okay, well, to still be sure that we are not using the wrong steps to get the correct answer, we're going to just use this rule right here. This is valid, at least. We chose this one, right? I believe you chose that. Or I just introduced it to you. Well, you can go ahead and make some research on that, but that's actually the truth. Okay, and here we go. To actually make use of this, we have f inverse of x outside, then we have function of x, composition of functions. So let's just try it out here. So we'll have this last part of the part. Well, f inverse of x is given to be this, okay? It is identical in both methods used. So we just use f inverse of x is equal to 3x cubed plus 1, like this, alright? Okay. Well, f inverse of f of x. Now, when you have f of x is here, okay, as the independent variable, the function is always written in terms of x. That means x right here is like a domain of the rule f. Having here f inverse here, f inverse of, now in place of x, in this one by comparison, we have f inverse, we have x. So by comparison, you see that in place of x right here, okay, f of x has occupied that place. That means this function f inverse will be written in terms of f of x, like that, instead of x. So in place of x, we're going to put f of x. So since f inverse is in terms of x, now we're going to put f inverse of x is going to be, in place of x right here, we're going to put f of x, right, like that. Don't just be confused, just the positions, right? So we have f inverse of x, right? F inverse of, let me write it in red, f inverse of f of x, okay, that will be equal to, this will be equal to, well, f inverse of x is giving us 3x cubed plus 1. So f inverse of f of x, now in place of x, like this, we put the x here. So now we are putting f of x is going to become 3. Now in place of x, we put f of x. Alright? F of x, like that, and cube of that, plus 1. And that's it. So where our f of x is said to be the whole of this. So we just have it to be that f inverse of x will now become 3 times, now in place of f of x we put the whole of that and we add it with 1. So what was that? That was just cube root of x minus 1 divided by 3. And this is 3 here, so we just put it to power 3, alright? Now we have it to be cube roots and it's raised to power 3. What happened? This right here will cancel out. So we just have it to be this and this cancel. Okay, and we are left with what? Well, we are just left with, sorry, not this and this that will cancel. This is the 3. So the power will cancel out with the root, with the cube root like that. And we are just left with 3, just having 3 times, in the bracket we're going to have x minus 1 divided by 3, and outside we just add it with 1. Again, this is bracket, which shows multiplication. So we cancel out 3 and the denominator. So we're just left with x minus 1 in the bracket, and outside the bracket we just have the plus 1. And what do we get from here? We have x minus 1 plus 1. We're going to get to 0. So we just have it here to be x. And what was that? Well, that was f inverse of x, of f of x. Okay, so what are we saying here? That since this satisfies this rule, it is equal to x like this. So since it satisfies that rule, therefore this or this is the inverse of the function f of x. Okay, thanks for watching this video, and that's what you get. Please subscribe to this channel.